Maybe there's some more of you coming since the rooms got changed, but I think you all should have got a couple of emails last week. You get emails last week? Good. All right. So expecting more students. Okay. So, but somebody wanted to say something first. Totally forgot about you.
Hey guys, I'm from.
All right. Okay, so anyway, so this is the new room, and it's going to stay in this room. There might be some more changes regarding the tutorials, but we will make I will make announcements in due time. But otherwise, this week is that's the only change this week, that the lecture is going to be on Monday. Okay, so where would you go? Just quickly, that since there were a couple of questions. I put a couple of things online, some definitions, so you can see it on my uni. So basically, there's three big words here. So if you so it's a definition of exogenous variables, so that determine outside the model, and so-called endogenous variables, which are determined within the model. Okay, so we have an equation. Some of the variables in an equation are exogenous, others are endogenous. And the endogenous variables are basically set by the modeler. Okay, so if I write up a model and there's some variable in there that is exogenous, by definition, I make an assumption about how the variable looks like. The opposite are endogenous variables that are solved by the model. Okay, so you have some theory, and the theory kind of determines a certain variable, like output, for example, and whatever the exogenous variables are, determine then, using a theory, how big this endogenous variable is. However, it's always an assumption of the modeler to determine that one variable is exogenous, the other variable is endogenous. Okay, so if there's GDP in a so we do today, or what we did last week, we can determine GDP in an economy. And just because we assume that's an endogenous variable, and that's why it's solved by the model. Okay, there's no per se reasoning where we could say that GDP is always an endogenous variable. Okay? Just because we are economists, we usually interested in determining the level of GDP or how GDP is growing over time. So we usually assume that GDP is an endogenous variable. Okay? But it doesn't mean only because it was endogenous last week, it is always like this. Okay? So it's always an assumption. So if you're in the midterm or in the final, there will always be a line saying this is an exogenous variable, this is the list of exogenous variables, this is the list of endogenous variables. And sometimes, I've flipped things on the head from lecture to midterm. It's just an assumption. Okay, an assumption can never be wrong. It can be reasonable, or you might argue that certain assumptions are not, realistic or something. But it can never be wrong. So it's purely an assumption to assume that certain variables are determined within the theory. Okay, so it's whatever. It depends what you want to describe in with your model. Okay, so keep this in mind. So how far did we get? We had our equilibrium condition here saying that production, the left-hand side, equals the demand for goods in the economy. Okay, it was a closed economy. There's no exports and imports there, but it had the government in there. So that government expenditures, investment expenditures, taxes, some constants. This part here describes our consumption function, and one variable that doesn't have a bar over it. So that was the endogenous variable. Okay, the rest is exogenous. So we always determine by this bar that we have here, for example, an exogenous variable that is not determined in the model. So here we have this very simple model, and we have only one endogenous variable, and this is y output. Okay, so this is the level of aggregate economic activity in this little model economy. So how is y determined? Well,
So we had this first equation, but then I told you that we can use this equation and put y on one side and the rest on the right-hand side. Why do we do this? Well, we have one equation, one unknown, and this was y, the level of economic activity, GDP. Right? So we want to solve for this. So we have a theory, a model, and we want to solve for the endogenous variable, which is here y. So we put y on one side of the equation, and now the rest on the right-hand side. Okay, so here it should become very clear what endogenous and exogenous means, because on the right-hand side we have all the exogenous variables. Okay, we have taxes here, investment, and government spending. Okay, and so far we have assumed that investment is an exogenous variable. Okay, so it's just simply given in this economy there's so and so many millions of dollars investment activity every period. Okay, a number of machines that are built or houses that are built. And that's it. It's not determined any further. Okay, so it's exogenous to this little model. However, all the exogenous variables determine the level of the endogenous variable. Okay, so we have numbers here potentially, all the taxes, all the investment spending, all government spending. We have some assumptions about these things, so we know that C1 is between 0 and 1, say, and C0 is a positive number. So since C1 is a positive number, but between 0 and 1, we know that this thing here is also positive, so the level of GDP is a positive number. Okay? So that's what we have. That's where we ended last week, and we can draw this thing. Okay, so here we have the same equation. And we can draw it. Okay? So what do we have here? We have on the horizontal axis income or GDP in this economy. And on the vertical axis we have the demand Z and the production. Okay? And these two things are the same at only one point, which we denote the equilibrium. So how do we get there? Well, if we have production here on the vertical axis and production here, or y here and y there on the horizontal axis, then we simply would have the 45-degree line, which was plot y in this economy. Okay? So if we have here on the horizontal axis y, we have y here. So if y is, say, 1,000, then exactly on the 45-degree line, here we would be at 1,002. Okay, so that's the 45-degree line. That's what we have. But then we should also look at the demand. Okay, so demand here was this. If you write it out, and you see, oh, you can see it. So how can we plot this demand in this this figure? Well, the variable that we vary here is income, y. Okay, so let's assume y is equal to 0. Okay, so if y is equal to 0, what do we have? So we have demand is, you can see this, right? I'll probably write a little bigger. Okay, so that's our demand in this economy. So move this up here. You see this? Okay, so let's assume output would be equal to 0. Okay, so what happens to the demand in the economy? Well, it does not affect the spending of the government. It does not affect investment spending, because these two things are exogenous. It also does not affect the taxes that are paid in this economy, T. Okay, forgot to put this bar over the T, because T, the taxes in the economy, are exogenous as well. So these three things stay the same. Same for C0, which is also constant. Okay, so keep in mind that these two things are constant. Okay, so these are just some numbers. I have some basically restriction that both are positive, and in particular that C1 is between 0 and 1. No other restriction put in there, but I assume that they are constant. Okay, so they are also exogenous in a sense to this system. Okay, so they're determined outside of it. Okay, there's no feedback of the level of economic activity and the spending of people on the level of C1. C1 is constant. Okay, so let's look at this case where where output y is equal to 0. If output is equal to 0, what do we have? In this case, the z, sometimes call it zz, it's the same thing. All right, sorry, is given as follows. Right? Because I assume that y is equal to 0. Okay, so if I want to plot this demand curve, and I look at the special case where output is equal to 0, it would be 0 here, then this term drops, and I'm left with this. Okay? And this I call, please say it here, autonomous spending. Oops. What did I do? Two seconds. Okay. All right. So this is autonomous spending. Okay, because it's independent of the level of output. Okay, so if I vary output or the income for this economy, this stays constant. Okay, so this is the demand. That's the demand in the economy, so that's the aggregate demand. When output is equal to 0, or that's independent of output, if you will. Okay, that's probably better. So it's not when this is 0, when it's independent of output. Okay, so if I want to plot this here, that's what it is. Okay, so this thing here is simply C0 minus C1t plus I plus G. Okay. So what happens now if there's some positive income in this economy? Okay, so what happens? Well, what happens when I move to the right in this graph? Well, if income increases, people will consume more. They will consume more than they will not consume more than 1 for 1, because the C1 is between 0 and 1. So if I increase my income increases by some amount, what happens? Well, if my income goes up, since I have this production function, consumption function, if this goes up, consumption will go up as well. How is this relation between an increase in income related to the increase in consumption? Well, we know that my marginal propensity to consume is between 0 and 1, so the increase will be less than the increase in income. Okay, so I had this little regression last week where I showed you that for Australia it looks like that the C1 is between 0.5 and 0.6, somewhere in this ballpark. Okay, so so this thing, certainly between 0 and 1, particular because I assume it. So this thing here determines the increase in spending when there's more and more income in the economy. Okay, so the only mechanism here is that there's an increase in income and people will buy more consumption goods. Okay, there's no effect on investment and spending of the government. So if we have this, what is the effect on the aggregate demand curve here? Well, what we need to know is we need the absolute value here at 0, and now we want to know what is the slope of this curve. Well, the slope of this curve is simply the marginal propensity to consume. Okay? So the slope of this curve is simply C1. Okay? This is less than 1. And that's a good thing in the sense that we will find an equilibrium where these two things are the same. Okay? If the slope of this curve would be C1 equal to 1, well, then the aggregate demand curve would look like something like this. And those two curves would never intersect. There would be no equilibrium. There would be no way that the production equals to the demand. However, if C1 is less than 1, then at some point these two curves intersect. And only in this point, what you call an equilibrium point, is production equals demand. Okay, so this is the point where the goods market clears. Okay, all the goods that are produced in the economy add up to all the goods that are demanded in the economy. Okay, so there's only one point, one equilibrium point here, where this happens. Okay, where demand equals supply on the goods market. And if we have this point, we can, of course, then determine what is the level of GDP in this economy. Okay, so that's one equilibrium point, and that's this one. Okay, and this income is, of course, given by this term. Okay, so that's the equilibrium that we have already derived on the previous slides. Okay, so we can look at this equation again, and most of you probably have already seen it. So we can split this up into some exogenous spending here and the so-called multiplier. Okay, and why is this first term called the multiplier? Well, we could think about what happens if any of these variables, say, increases. If, say, the government increases spending by a small amount, what happens to this little economy? Okay, so what happens if, say, the government increases government spending by a small amount, or, say, increases or decreases taxes by a small amount, or for whatever reason there's a change in government investment spending? Or you could also think about what happens if there's an increase or decrease. Of course, they can go both ways. Of C naught, the autonomous part of consumption spending. So what happens if these things change? And keep in mind, this is given our assumption that we made so far, that's basically a question you can ask, because here we assume there's some change in exogenous variables. Okay, so we cannot ask what happens if GDP goes up or down, because that's the variable that's determined in the model. Okay, so we cannot ask this question with assuming that GDP here or Y will change, because it's endogenous variable. Okay, but we can ask what happens when these exogenous variables change to Y, which is endogenous. Okay, so what happens in this case? Okay, so let's do it graphically first, and then we come back to what we call this multiplier and autonomous spending. Okay. So what do we have in mind? We have in mind there's an increase in government spending, say, by $1 billion. Okay. So what happens in this economy? Well, there's a number of effects. So if the government increases its spending, say the initial increase is basically the length from A to B, what happens to the economy? Okay, so we have an old equilibrium. At point A. So what happens to this economy if the government increases spending by AB? Okay, so that's the change in government spending. What happened in this case? Well, of course, there's an increase in demand for this economy. So you might think the economy moves from point A to point B. But what is the case in point B? Well, in point B, the demand for goods is higher than the supply of goods. Okay? Because the demand for goods would be this length, and we only produce the old output. However, what happens? Well, there's an increase in demand, so firms will also increase their supply. So they will build more goods, so workers will work more, or more people will find work. So what happens? The income of everybody goes up. Okay. So there will be a feedback effect into the economy. So we move up to a new equilibrium, say this one. Okay, that's the next equilibrium, point C, where demand is equal to supply. Okay. So that's the first effect. So in point C, we have an increase in government spending and an increase in production at exactly this amount. However, if we are in point C, what happens if we compare point C, let's call it the next equilibrium. What is the situation in point C? Well, in point C, output will be higher. So as I said, workers will have more income. If they have this, what happens? Well, they will consume more. Right? So on top of the initial change in government spending, there will be an initial additional increase in spending in this economy because everybody has a higher level of income, everybody will consume more. Okay? So there will be a next step, another increase, and this increase is basically C to D. That's an increase in consumption. Because output went up. Okay, so we have a next step, output goes up. In this economy, income goes up, people will consume more. Okay, so we are now in point D. So the income is, the demand is higher, so the next step will be moving from D to E, where the level of output in the economy is equal to the level of demand in the economy. Okay? So you have another step. So we move from point A to point C to point E, and of course, once we move from D to E, output will go up again, and people will consume again. So they will consume more again, and we have the same mechanism. The increases become smaller and smaller. Right. So the increase from A to C is larger than the increase from C to E. But essentially, this process will go on forever. Become smaller and smaller. At some point, we can just say, like, just forget it. It's like tiny amounts that are increasing here. But this process will go on forever. Okay? And this process is called the multiplier. So if we think in numbers, just like jump back to what we had before. So that's page 21. We have this multiplier effect. So if there's some exogenous increase in demand in this economy, we have successive increases in production. And we have successive increases in demand in this economy. Okay. So what determines these increases? Well, it all comes from the production, the consumption function. Okay, so the consumption function here again was given as this. Okay, so if there's an initial increase, say, in government spending by $1 billion, what happens? Well, first the demand goes up, so there's an increase in production by $1 billion. Okay, so the first round effect. And then there's a second round. So output goes up by $1 billion. So the income of people goes up by $1 billion. What do they do? Well, they consume a fraction of it. And the fraction is exactly C1 times $1 billion in the next round. Okay? So there's an increase by $1 billion times C1. And then again, output goes up by C1 times $1 billion. And then again, this additional income will create even more consumption. So we have the next round. And that would be simply C1 times C1, because the increase is C1 times $1 million of income, and C1 of this, the fraction C1 of this, is consumed additionally. So this process goes on forever. And if we have this and it goes to infinity, we can rewrite this thing here as 1 over 1 minus C1. Okay? So you maybe don't want to believe me that this is the case. So I gave you the proof here. Okay? But the proof is not... so either believe me or you it won't be in the midterm. Okay? So that's just in terms of numbers. What do I have here? Doesn't make sense. So let's assume the government increases government spending by $1. Okay, what happens? Well, we have assumed that C1 is 0.55, or that's a number I estimated for Australia. So what happens? So we have all these rounds. So we have $1. In the first round, that's the increase in government spending. Okay, there's a next round. That's an increase in consumption, and that's 0.55 times the $1, which is, of course, 0.55 cents. Okay, or 55 cents. Okay, so that's an increase in consumption, the first round. Okay, so then income goes up by 55 cents. So people will consume again. How much? Well, the fraction of 55% of the 55 cents, which is 30 cents 25. Okay, so there's another increase in consumption. Okay, so many cents. Okay, and there will be a next increase, and will be 1663, etc. Okay, so these numbers will become smaller and smaller, and if you add them all up, you get to $2. So you add them all up, you get to $2.22. Okay, so if you do this to infinity, you end up at $2.22. Well, I already showed you the the equation telling us how the multiplier looks like. Well, we could also simply put the C1 value in here. So we have 1 over 1 minus 0.55, which is 1 over 0.54, and it's 2.22. Okay? So that's the same thing. So the increases are all positive, but they become smaller and smaller. So this thing converges. If we add them all up, to $2.22. In this example, when the marginal propensity to consume is exactly 0.55. Okay, so that's the multiplier in this case. So initially, government spending went up by $1, but GDP would go up by $2.22. Okay, so there's a multiplier effect, and the multiplier effect is 2.22. Okay, so government spending, if the government decides in this model to increase its spending by $1 billion, GDP in this economy will go up by $2.2 billion. Okay, so there's no money markets here, there's no feedbacks with interest rate, etc. This comes next week. But in this very simple model, that would be the multiplier effect here, given our assumptions on the numbers here. Okay, so now let's talk about this. Okay, so we determine output, and just summarize what we have here. So if there's an increase, an exogenous increase in demand, we have an increase in production, and if this multiplier is greater than 0 or greater than 1, then the increase will be greater than the initial increase in output. Okay, so let's just jump back to here. So I've assumed that this multiplier in my numerical example is 2.22, or C1 is 0.55. So of course, if this marginal propensity to consume becomes relatively big, so it's close to 1, what happens? Well, this curve has a larger slope. Okay, so this means that the increase will become bigger of an exogenous spending increase. Okay, so if I have here my 45-degree line, output, and spending here, and here I have my spending equation. So if I increase spending by this amount, then I have an increase. So I increase spending by this amount exogenously. We have endogenously this increase. Now, of course, if my marginal propensity is bigger, the slope of this curve will be larger. So if I increase the same thing by starting at the same equilibrium, but here is Z, and this is Z was larger, C1. What happens? If I have the same increase, then this curve goes through here, and the new equilibrium points up there. Why is this the case? Well, the multiplier was 1 over 1 minus C1. So if C1 is a value that is very close to 1, so make C1 equal 0.95 as an example. What do we have then? And the multiplier is this, which is 1 over 0.05, which I think is 20. Okay, so if the marginal propensity to consume is very large, so if there's an exogenous increase in spending, an increase in income, and a large response of consumption spending to it, this increase becomes bigger. So the multiplier would be 20. And of course, if C1 would approach 1, then this increase would go to infinity, right? And that's why basically the demand function has the same slope as the output function, then so that would be the case where this red line there has the slope 1, then there will never be an equilibrium, or the multiplier would be infinity. right? So that's the that's how far we can go there. Okay, let's jump to page 26 and do some accounting, since we had some accountants here earlier. And do some accounting for a closed economy. Okay, so again, there's no exports and imports, so there's no trade with other economies here. Okay, just want to give you one little accounting result here that you should be aware of, and then we start with financial markets, I think. Okay. So let's talk about what private people are saving. Well, they have some income, which is output every period, Y. And some of this income they consume, and the rest they have to save. Okay, so if you have some disposable income after taxes, right, you can do two things with it. You either consume it or you save it. There's nothing else you can do with it. Okay, there's only two options you have. You eat your income or you save it for another period, say. Okay, so in an economy, what this has to always hold. Okay, so this is simply an accounting exercise what I do here. This always has to hold in a closed economy because I don't consider exports and imports here. Okay, so this always has to hold. So your after-tax income can only be consumed or saved. Nothing else you can do with that. Okay, so if I take away all my consumption from my disposable income, I have my savings. Okay, so my disposable income is of course Y minus T. So savings in this economy always has to be Y minus taxes minus consumption. Okay, this always has to hold. Let's look at the goods market equilibrium, where again all the goods that are produced in the economy are either consumed, become investment goods, or bought by the government. Okay, nothing else can be done. Okay, so they're either bought by consumers, firms, if they're investment goods, or the government if they are valuable to the government. Okay, so I have these two equations. Whatever. So then I simply take away taxes on both sides of this equation. Okay? So if I do this, let me just do this here, but you already have it here. So I have C plus I plus G, and I subtract taxes on both sides. So if I do this, I have output minus taxes on the left-hand side, and C plus I plus G minus T on the right-hand side. Okay, I can do it. I just take, subtract the taxes on both sides of this equation. Okay, and then the next step is simply to bring C on the other side. Okay, so I take minus C on the left-hand side and on the right-hand side of this equation. So if I do this, I have Y minus T minus C equals C plus I plus G minus T minus C, and of course then this C and this C cancels, and I have Y minus T minus C equals I plus G minus T. Straightforward. Okay? So of course you have this here. Why do I do this? Well, this thing here is the same as this thing. Okay? There's two equations that I have. One was the goods market equilibrium, and the other one describing public savings or private savings of the in this economy. Okay. So I can combine these two equations. Okay. So I have S equals y minus t minus c, and y minus t minus c equals I plus g minus t. Okay, so I have two equations, and the reason why I have rewritten everything is that I have here and here the same expression. Okay, so if this holds, I know that S has to be equal I plus g minus t. Okay, so private savings and an economy have to be equal. They always have to be equal. That's simply an accounting entity. Always have to be equal to investment plus government spending minus taxes. Okay. Remember, this is a closed economy. Okay, so exports equal imports equals 0. Okay, this always has to hold, and that's what we have here. Okay, so this has to hold every second in this economy, or in an economy. So we have I minus S equals T minus G. Okay, this always has to hold in an economy. So what happens, for example, if the taxes are larger than government spending? Or let's do the Greek case. Spending is greater than taxes. Okay, so the government spends more than they receive in income. And the income for the government is the tax income that they receive. Okay? So simply looking at this, what has to hold in this economy? Okay, so what happens if these two things are the same? Or not the same, if these two things are the same, but spending and government tax income are not the same. So if the government spends more than it receives in tax income, what is the effect of this on T minus G? Well, G is bigger than T. So the right-hand side of this equation has to be negative. Okay? So T minus G is negative. Okay? So that's simply an assumption. So let's assume spending is bigger than tax income in the economy. What happens in this case? Well, we know that because this identity has to hold, this has to hold every period. We know that this thing has to be negative as well. Okay, so we know in every second here that savings have to be greater than investments in this economy. Okay, so if the government runs a budget deficit, we know that the public has to save for this deficit. Okay, so if spending is greater than tax income, then the saving in the economy have to be bigger than the investment level. Okay, there's no causality yet here. Things just have to add up. Okay, I didn't tell you yet why then this response is the case, but this is simply accounting. Okay, so it's not a theory yet, it's simply accounting, so there's no causality here how then investment goes down or savings goes up. But that's the simplest way to write these things. And this has to be the case all the time. Okay, so basically in the next couple of weeks we derive some theories how these adjustments may come how that can take place. But we also know that if the government budget is balanced, so if the income T is exactly their spending G, in this case, we will also know that in this case, investment will be exactly equal savings in an economy. Okay. We know that this is the case. Okay, so that's simply some accounting. There's no causality here, but we know that this always has to be the case. This equation always has to hold. Okay. And given that most of you probably did not print out the slides for the next chapter, which is called Financial Markets, I will have to tell you that you should start reading chapter 4 in the textbook, and I will continue right there.